Woohoo. Hello, everyone. Thank you all for choosing this session. Not all my slides are going to make you hungry, but the word flaky has some interesting meanings. So this is a sausage roll, and if you're from the north of England, you love eating these things. They're probably one of the best snacks you can go about and buy, but they're not exactly very good for you, as you can probably tell. Puff pastry. Puff pastry is flaky by design. We want puff pastry to be flaky. If it wasn't, you wouldn't be very happy about it, and you probably even wouldn't call it puff pastry. The human body has a reaction to when something has gone wrong. So basically, I screwed up here. That's not actually me, but that has happened to me on several occasions. And our body reacts by being flaky, and we get rid of the damage we've done, and we come back. Chocolate. Again, you can probably tell I like the chocolate. Again, flaky by design, but it's also incredibly brittle instead of incredibly crumbly. And then everyone has one of these people in their families or in their friends group. That person who says, you're going to come for a beer on Wednesday? And they're like, 100% coming for a beer. I cannot wait for this. And then you get a message at like 11 a.m. on Wednesday, or might not be able to make it, but I don't know yet, I'm not sure. And then at like 8 p.m. they say no, and you're all ready and good to go. So the word has a lot of meaning. However, this is commonly what this audience would associate with flaky. We come into our offices every day, and we see this happening. So we come in, everyone's dead happy, and this is so depressing that this is now somebody's role, but this is what's happened to our industry. We come in, the build is red, and some poor person has to sit there making it green. They go to lunch, it's green. They come back from lunch, it's red again, and they just spend their day doing that. I cannot think of anything worse. But I imagine if I asked you to put your hands up, I'm not going to do that, but a lot of you have probably had that role, or there's someone in your company with that role. And we designed that. We don't think we did, but we designed that flakiness. We're allowing that to happen. We engineered it to be that way. And it's our fault that that exists. So let's have a look at why we automate. So automation's now obviously a huge part of any approach to testing. It's become this, it's actually taking over to some degree. But a lot of times we don't consider why we're actually doing it in the first place. So I consider there's two reasons why we do it. Our product did something that made someone incredibly happy, and that person is someone who matters. They're very important to us. It could be a customer, it could be someone in the team, it could be a user further down the line, but it's made them happy, and they want it to stay that way. So we write an automated check that checks that it's going to stay that way, it's going to make them happy. Or the product's done something that made someone who matters incredibly sad. They just went to do their job one day and your software just crashed, and now they're sad. And we don't want sad people in the world. The world is full of sadness as it is already. So we want to do our best to keep people happy. So we automate these scenarios because I want to be told if they ever change. So if any of these situations that I've automated, if they ever change, I want to be told immediately. Because I need to then go and look in and see if that change is important. Does that change matter? When our builds go red, it doesn't mean that there's something broken. It doesn't mean that the software is full of bugs. It means something is not how it was the previous day or how it was in the previous hour. It's changed, so we have to go and see what that change was. So having someone coming in, fixing them all day, they are going through that process. So that's why we automate in terms of automated checks. I'm going to use the word checks. I'm not going to get into that today, but if I ever say the word check and you don't know what it means, switch it to test, and it means exactly the same thing. That's how wonderful that works. So now, obviously, we're talking about the context of automation. So what are the signs of flakiness? So I've listed a few. The first one, as we've seen, is red, green, red, green, red, green, red, green. It just never constantly stays in one of these states. Now, if it was constantly green, we all have the tendency to go, nah, it's green. Happy days, carry on. If it's all red, then we point in and we actually start jumping in, is this correct? Should we delete this? But when it goes intermittent, we kind of, nah, we'll deal with it. It's been like that for years. Like, who cares? Like, no one's bothered about it. And then we have the emotions. So as I said, that person who's doing that job all day, they must be incredibly bored. Like, I've done that job, and it is incredibly dull. I don't learn anything. I get no satisfaction. And what's funny about that journey is, as automation engineers, building your framework is like the best thing you can do. So energetic. It's like, yeah, I'm learning new tools. And as soon as it's built and someone says, now write loads of automated checks, you're like, oh, really? I want to keep building crazy stuff and fancy things. So we actually don't put as much effort into that bit, which is where we're trying to make people happy and not stop them being sad. And then time. You have this huge time sink. Like I've literally spent, I'll tell it in another story, but I literally spent about 4 hours trying to get Appium to click a button. I would never get that time back. I could have clicked that button probably about 4 million times in that time period, and I'm never going to get that back in my life. So, you realize that you're wasting too much time on these things. And then the learning stops. I don't know what your views of testing are, but for me, testing is a learning process. I want to learn about this product. And if you're stuck in this cycle of fixing things that you already knew, you've already got that knowledge, you're trying to see if it's changed, who's learning the new stuff about your system? There's lots of developers working away, building new features. How are we learning what they're up to, what the product now does? And how do those new things impact the existing automation? We don't have much time to look at that. And then we have poor coverage, and we have poor coverage because we're too busy fixing the previous coverage. And even worse, we're too busy to acknowledge that the coverage isn't the same anymore. When we wrote all the automation, it may have looked like this, but now we've gone through so many changes, it looks like this, and we're not covering the areas we should look at. And then we have the reasons why. We love the reason why. It's the internet's fault. The internet doesn't work. We need to fix it. Like, you can't fix the internet. It's not like IT Crowd with a little box like this. This is in IT Crowd. This was the internet. You can't just break it. Or we like to blame Selenium. We should probably just blame Simon. It'll be easy, right? Everything's Simon's fault. But we blame Selenium. We go, it's Selenium's fault. It's poorly written. It's poorly coded. I'm really angry. And like the story Simon sold, I'm not going to use your tool anymore. Like, well, of course you are. Even if you went and got another tool, it will use Selenium. And then we blame all the other tools, and then we always have that person in the team whose fault it is. It's Ashley's fault. I bet Ashley wrote that test. Let's have a look. Oh, it was Ashley. I bet I know what the mistake is. And you never go and tell Ashley this. You don't go and tell them, oh, you keep making the same mistake. I could probably help you stop doing that. No, instead, you take the high ground and go, I fixed it. I fixed this. This is now my automated check. But we never help the other person learn, so they're going to continue to make those mistakes. And then, we like to blame DevOps now. Why not? DevOps is new and shiny. We'll blame them. We used to blame Agile, but now we'll blame DevOps. And then the data is the obvious one. Someone stole my data. The application swallowed my data. No, you didn't look after your data. It's your fault. You didn't put it there. Or did you run tests at the same time? Oh, you've stolen my data. How dare you run tests at the same time? So we have all these problems, but as I said, you can see the reality is it's us. We engineered them. We designed them that way. We chose the tools. We decided what to automate. We decided how we would automate it. We've made all these decisions, yet we like to blame the things that we've chosen to be part of it. And it's not ideal. So we've no idea if this slide's going to work, but let's try it anyway. I want you to all just calm a little bit, and then just nod your head, just tilt your head forward a little bit. We'll see if it will play. No, it's not going to play, but that's okay. And just take a moment to realize it's going to get worse. It's going to get incrementally worse, and I'm quite sad about it. I love this guy's face. He has no more fucks to give. He is out of them. He's literally, look, he's even got his hands in his pockets trying to find some more, and they're just not there. And now he's resorted to just wearing a sign, just probably walking around his office. Yep, we're screwed. And let me tell you why I think it's going to get worse. So the first reason is there's a huge emphasis to push people out of testing and push them into automation roles, which is flawed because testers historically were not very good at saying what we did. So historic manual testers, QA, whatever we want to call them, they used to say, I just write test cases and I run them, and I just tick a box. And then you go, why did you test that? And they go, because. Because of what? I don't know. It felt like the right thing to do. You go, okay. What did you learn? I learned that it works. How did you learn it? The spec says it should work, and it works. Okay, right, you're very clever. And they are very clever. And they never shared it, and we never explained what people were doing. When you test, we use the spec, but we using it so loosely. It might say that there should be a login form on the screen. That's all it says. So you might look for the username and passwords and the submit button. But as a tester, you would have looked at a hell of a lot more than that. But that's not in the spec. It doesn't matter. And then we put a big tick on it. So when automation came along, of course it made perfect sense just to pick up the test cases and drop them on some poor person's automation desk, and they would sit in the dark corner and automate them for the rest of their life. It makes perfect sense. But when we realized that the testers were doing a lot more than that, now we have a problem because we've got rid of them all. Well, in a lot of companies, we've got rid of them. We're forcing them to learn to code. And there's a lady called Dot Graham who says if you push a good tester out, well, she didn't say this, she introduced me to this. I always forget who said it originally, Bands Hubel, I think. If you push away a good tester, you gain a bad programmer. And that's part of the reasons now why we have such badly written automation, because they haven't had the training needed. Another reason why, there is a new tool every day, every week. We went down the vegetable route, and we went down the fruit route. Now we're on to drinks. I'm not entirely sure what's going to be next, but it will be something like star signs, or perhaps we'll go back to metals again. But there's a new tool every week. So now we're just, we're going back excited again, and we're just taking these tools left, right, and center. And what's even worse is software's evolved. So these package managers, we can just download anything these days. Oh, I need something that does this. NPM search. Oh, download. Does it work? Yeah, it works. Carry on with our day. We just put like a massive file into our code base just to do one thing, and it does the one thing very well, and now we move on. So that's going to be problematic in the future. But the main one is as well, all these testers we're pushing to code school, we're not training them how to be programmers. We're training them how to use the tools that they want to use. So we teach them how to use Selenium, and you teach them just enough Java and just enough Ruby to know how to make Selenium work. So whenever anything goes slightly different, they don't know what to do. They get stuck. They go to Stack Overflow, and they start trying to research. So I do think there's a lot of people currently in the industry that basically don't have the right skills. So all they do all day is they literally are zombies. They walk around going, Selenium, I want Selenium. Everything I say is Selenium. And this zombie analogy works quite well, because even if they could find a way for zombies to use their brains, a lot of these people are refusing to use their brains because their life's easy for them. They're an engineer now. I got 10 grand more a month. I'm not QA anymore. I'm an engineer. Why would I want to go and learn and do some more stuff? So, it's reasonably why that is part of the problem. Now, back to the flakiness problem. We seem to want to hide it. There's been a few talks here, and I've seen lots of talks everywhere else. We're now building these crazy complex systems that pull flaky tests out of the run and put them in quarantine and put on another queue again for some poor person to go to the quarantine queue and just sit there fixing them all day. Or we build incredibly crazy reporting to try and work out why they're flakiness, but we do it from the basis of what we already have. So we go and read the existing code and look at the tools to try and work out why it's flaky, but we don't know what happened previously. What was the intent? What was the thing we were trying to automate? We don't have that information, and we should. So if you do have some flaky automation, it's an invitation to go and explore it. Go and find out why it is behaving why it is. Is it the tools that we've used? Is it that the logic's now completely flawed? And try and keep some of that data. The inspiration for this talk was the huge post from Google. And they went and did exactly this. They didn't cover it up. They tried to do analysis, but they did analysis on what they had at the end. So they started looking at the size of checks, how big the megabytes they were, how much memory they used. And they did their analysis that way. And they then claimed that the ones that were bigger were the ones more likely to be flaky. Of course. If they're longer and going through more things, that means there's more steps. Of course they're going to be more likely to flaky. They've got more libraries in them. But they're not the cause. It's not the tools. It is, as I said, it's us. So I don't want you to cover it up. I don't want you to hide it. Please stop building these crazy tools to hide all this information. Use it as a trigger to go and learn about your product, learn about your tools. So I like to study testing, and I like to just stare at a whiteboard, doing apparently nothing, my girlfriend says, just staring at a whiteboard. And then I end up sometimes creating something that I think is worth sharing. And the one that I want to share is basically a new heuristic, a new mnemonic called sacred, which is going to go through the process of how we should be trying to design some of our automated checks. And also at the same time, I quite like the word sacred because we should be treating these automated checks, these, again, I don't really like the word sweet, but all these checks, they're incredibly important in our process. In the way we are moving, you are going to have to be somewhat dependent on having some automated checks because we're trying to move so fast. And we need to give them respect that they deserve. So the first one is state. I'm very privileged that I get to visit some companies to see how they're implementing their automation. And the amount of times that I don't see this distinction between state and the actual automated check itself. They have the whole thing in one big long script, and they don't separate these concerns out. So when I talk about the state, in order to do something on our app, we have a flow we want to do, and then we have some assertion we want to do at the end, and there's some reporting. But we need to put our application in the right state in order to be able to build our automation from. So we need to be able to control the data. We need to be able to put all the data we need in the right place. And there's many ways we can do this. The truly worst, awful way to do this is to have a big database that you import at the start of the whole test run, and it's nice and small and compact and only has exactly what you need, and then we import that and then our tests run, which is absolutely nothing like our production database, which has 25 billion rows and is really huge. So there's another way is we can add the data as we need it. We can have one database and just keep adding, but we need to think about it is what I'm trying to say. And now the same with config. Systems are insanely complicated these days. You can turn stuff on and on, left, right, and center, and you can actually, in some cases, there's some huge products out there. You can make a completely brand new product that it was never designed to do just by turning some stuff on and on. And we need to be able to programmatically control those things. And if we can't, you're going to struggle to be able to automate it. And also then the impact of not doing this is, as I said, the data. So we have a lot of issues. I've seen a lot of issues where we all run our tests on the same environment. We share data. People steal our data. Someone logs on middle of the test run and changes the config, and then they all fail after it. We need to eliminate that and stop that from happening. And the people involved, I was really, Katrina's keynote this morning, we don't involve enough people in this process. If we start talking to the developers and the ops, and even the BAs and product owners about testability, we can now have those conversations up front, and our products will be designed to be testable. If you can't test your product manually, you won't be able to automate it. It really does work that way. It's quite simple. So we need to think about the state up front. So the next one is the algorithm. Basically, the flow that we're going to take. We're at the Selenium conference, so I'm going to use the context of the UI. We want to click some stuff. We want to type in some fields. We want to get some attributes. We want to look at some classes. We have to design that and model that quite carefully. And the decisions we make, when should we go to the next screen? When should we look this? How long should we wait for these things? And that's back to now what I said at the start. We're actually not very good at it. We're actually not very good at realizing what we do. It's like, oh, I just clicked on the UI and I typed this and I typed this password in and I moved the mouse and I clicked next. I'm going to tell Selenium to do exactly the same. You didn't do that. You clicked on it and you waited that split 200 seconds until the cursor appeared on the screen. Then you started typing, and then you moved the mouse just exactly the right direction, and then you went down to the button, and you did a lot more than what you think, and we're not very good at acknowledging what we did. And if we get better at that, we can start instructing the tools like WebDriver and the other products out there to do that better for us. So we need to get better. And then we make poor decisions about the frameworks. So, the Selenium contributors here will love it. They make a mistake sometimes, and they break a few things, and the whole Selenium community goes mental until that one person comes along and goes, oh, send keys isn't working. Here's a big JavaScript execute thing you can do it with instead. And everyone goes, oh, fantastic. And they change their whole suite to now use it. And they never think about it again. They never check the bug to see when the bug has been fixed and revert everything back. And now we've got loads of these things in it. It's like there must be massive abuse of the actions class out there just to make this one page do something that you probably could get someone in your team to just fix and contribute it back to Selenium. But we don't do that. And also, we have very poor tool knowledge. So, there's been suggestions to learn the source code. or go and look at the spec. Very few people I meet who do Selenium a lot, and they come to me, and they're like, Richard, I want £65,000 a year. I'm going to do all this awesome automation. And then I ask them to model how Selenium works, and they just stare at me. Do you understand what the wire protocol is? What? How does that work? Do you understand how the servers hang together and what's going on in the browser? They don't know. You might not need to know, but if you're going to build big suites, it's about time, I think, we started digging a little bit more and started sharing some of the knowledge we have. So this one is very important. So codified oracles. An oracle, if you're not familiar with the term, it's not a database. Well, it is a database, but it's not one we talk about. We don't want to talk about Oracle. But oracles, they're basically how we decide if there's a problem. As humans, our heads are full of them. Does anyone spot a problem with this slide? If I go back to these two slides, and you look in the top left, is there anything wrong with this slide? Yeah, so you didn't have that oracle like 10 seconds ago, but now you do. So now you're going to look at the rest of my slides and be like, has he colored it in green? Because we're now aware that there might be a problem here. So I said, our heads are full of them. And again, we're not very good at identifying the oracles that we have. We're aware that we look at stuff, but we're not very good at then instructing the tools to do this. So sometimes we take the spec, and the spec will say, successfully log into the application. And you click login, and you end up on the home page, and you say, brilliant, it works. But during that process, you were looking at the whole screen. No big red elephant appeared on the screen. You're not going to put that into your automation. But you noticed that there was no big elephant on the screen. So we need to be more aware of what we put into our assertions. So our assertions are basically codified oracles. It's how we say, we're asking the code to say, can you ask this question of the application and see how it compares to this answer? And at that point, if they're not the same, please tell me, because I think that's something has changed, and I want to look at that. So we need to get better with the assertions that we write. Otherwise, they might carry on going green, but there could be something else on that screen that's not there. So the other thing with this is to constantly go back and review our assertions. As you learn, you will learn constantly. Every single day you will be learning about your product, but you never tell your code what you've learned. And right now, until AI is mainstream and you can have it in your company, which is going to be a while off, your solution isn't going to learn. It needs to be re-educated. It's stupid. As soon as it breaks, it doesn't know why it broke. It doesn't know there's a bug. So when something does change, there is not a bug. There's just a change. We then come in as humans and put that change into context and go, yes, that is a bug, or no, a framework needs changing. Or even on some occasions, we've had it where you go, well, that's a pretty cool feature, actually. I think we should keep that. And then you go tell the product owner that the thing can now do something amazing. So this is really important to think about how we decide what is pass and fail, what is change and not change. So we have reporting. So now we need to think about, well, what do we want to report? And who are we reporting for? So we're building these frameworks again, and we're adding in lots of plugins now to control all this reporting data. And is it a simple case that we only care about pass and fail? Or when they fail, do we want the system to tell us as much information as possible? Do we want it, we just had a talk about screenshots. A screenshot is a fantastic way to look at the UI and go, what went wrong? But if you can get the logs, if you can get the output of what your tool did, if you can get a snapshot of what the data currently looks like, and put all that together, you can debug this a lot quicker and then fix whatever the issue may have been, or easily log the bug with a lot more information to help the person do, whoever's going to fix it. And we need to ask everyone, what do you want from this automation? What reporting do you want? I might just want a pass and fail, but my product owner might want it mapped to feature stories so they can find out. And also now I've seen a lot of people put all this into their test suite. So they actually put all this data and this process of creating all this report is actually then done at the time of execution. So we're waiting in sometimes, one of the ones I had recently was 20 minutes for this reporting engine to do all the data, and the build would stay in progress. The reporting at that stage isn't important for me to know if the product's okay. That's for stuff later on, so don't put it as part of our builds. And if we put it as part of our builds, we introduce more flakiness because we're waiting for these things to execute. And then the execution. So we need to decide up front, where are we going to execute these automated checks? Are we designing them to run locally? Are we designing them to run in a grid somewhere? Are we designing them to run on the cloud? The magical cloud. Or are we designing them for something completely different? Are they being designed for one specific environment? We need to consider this. Is it an environment that we have full control over? Can we do stuff with it? Is it shared? We need to put that into our design up front so that we don't introduce flakiness by having something that's not designed for where it's being executed. And we need to do this with all the people now. Like, obviously, if you do have an ops or a DevOps team, they are now prime candidates for this, and lots of testers have moved into that space as well. And they are the prime people to help us control these environments. And the way tech is going now, we should all be able to spin up masses of environments within a few minutes. But obviously, the way software is, there's people right over here still, and there's people long over there. So it's going to take a while till we're up to it. But another one is the underpowered thing. I don't know about you, but I have a very fast laptop. And whenever I run stuff, it runs at the speed. It's insanely quick. And then I go and put it on the cheap-ass DevOps machine that we bought in AWS to save some money. And then everything slows down and things start to fail. We need to consider these things to avoid these issues we might have with environments. Okay, and then the actual goal of this whole thing is to be deterministic. If our automation is not deterministic, it's going to cause us pain. It's going to cause us to lose a bit of value. It's going to cause us to slow down. And we can't slow down anymore. We are moving ridiculously fast. Software, if any of you, I've only been doing this for 12, 13 years, but if you look back on what I was doing 10 years ago and how my systems are architectured, and hosted, it's nothing like this at all. Nothing like it was. So we need to be deterministic. I am going to ask you to put your hands up just for 1 second. How many of you have seen every single one of your automated tests fail? So as you design a new automated test, you should make it fail there and then. Because then you at least have an idea that your oracles are correct and your flow is roughly correct. Don't just commit it because it went green. Test it a little bit, and then you get a bit meta now. Who tests the tests? But we do have to do some things to it. We have to try and run it, make it fail, so we at least know that it can fail. Marcus just told me a story that his site went down. The whole site went down. You couldn't even get to the site. And 23 of their automated tests still passed. How does that work? They're not deterministic, so we need to think about this. And as I said, if there's too many moving parts, that interferes with the problem of being deterministic. So as I said, there's this whole industry now of putting layers upon layers of our automation. And in some cases, we are introducing too many layers. I've seen implementations of Cucumber that I could just write in code. I could just write the exact words they've written as a method, and I wouldn't have another issue, another tool in my stack. So we need to think these decisions. So Katrina made everyone take a picture. I like that idea. I don't want to be in the picture, though. But I want you to all take these questions back to your office, go through some of your automated checks, ask yourself these questions. Are they on the right layer? Are they using the right tool? Do I know enough about this tool, enough about this functionality? Because we often build these huge suites now, and we never go back and look at them. We never go back and see whether they should stay or need to change. We just know that they're green. And the bottom one is incredibly important. Should I automate it at all? One important thing that a lot of automators don't realize is you actually spend a very large proportion of your time testing. The process of writing an automated test is testing. You're looking at the product, and funny enough, you're normally looking at it from a layer that you would never normally look at it at. So you do actually find lots of bugs. I did some analysis at a previous job, and we probably found the automation probably found about 5 bugs a month, maybe. But as we were writing them, we probably found about 200, because that's where we're doing the testing, that's where we're learning. So I need to quickly, as I said, there's many other options available, so don't get fixated on tools, don't get fixated on automation. There's lots of ways to solve our testing problems. If you want to know some more about me, you can find it out on there. I co-run Ministry of Testing these days. I've created a new namespace with a guy called Mark Wintering, who's on later, all about automation and testing, because I think test automation is a bit tarnished these days. And there's a funny whiteboard testing YouTube video. and then there's the blog and stuff like that. And very quickly, I want to thank White October for allowing me to share the next slide, sorry. There's a guy in our community called Christopher Nordstrom, who sadly, his daughter, Linnea, has a very aggressive form of cancer that they can't get treatment for in Sweden. So they've had them to go to Mexico. So someone in the community asked, can we build a calendar and make it fun of silly pictures with MOT? So this is Simon in his shower at home. And all the proceeds from this goes directly to Linnea as well, to their fund. So if you want a funny calendar in your office, then consider this. It's only $9.99, I believe, and all the money goes to them. So thank you very much, and enjoy the rest of the conference.